This video is just a quick explanation on how to add or subtract radicals. You can think of radicals as having like terms. Like for example, if I have 3x plus 7x, x is an unknown. We don't know what it is. It could be cats, it could be dogs, it could be turtles. We don't know what it is. But I have 3 of these things plus 7 more of these things equals 10 of them. The same thing is true with radicals. If I have 3 radical 5, or 3 square roots of 5, plus 7 square roots of 5, this means that I have 3 of these things, or square root of 5 plus another square root of 5 plus another square root of 5, plus 7 more of these things. So that would be 7 more square roots of 5, so for a grand total of 10 square roots of 5. So whenever you're adding radicals together, you're simply counting how many of them you have. You just have to make sure that they are like terms. Just like when we had 3x plus 7x, they are like terms. If I have 3x plus 7y, they are not like terms, and you can't add them together. So if I have 3 square roots of 5 plus 7 square roots of 6, those are not like terms, and we cannot add them together. They'd be stuck. That's as far as I can go if I was adding things that are not like terms. So whenever you're adding or subtracting radicals, you want to make sure that they have the same root, or the same number inside of the radical that you're adding or subtracting together. So let's do a couple examples of this so you can see how it works. Let's say we've got 5 square roots of 7 minus 3 square roots of 6 plus 4 square roots of 6. Okay, we're combining like terms, we're adding radicals together. How many square roots of 7 do I have? Well, there's 5 of them. Minus, do I have any more square roots of 7? No, I don't have any more square roots of 7. What I do have like terms of, though, are the square roots of 6. So I'm only looking inside the radical to see what the like terms are. And then the numbers in front that are being multiplied are simply telling me how many of them I have. I've got -3 of these things, the square roots of 6, plus 4 of them of the same exact thing. So -3 plus 4 is 1 square root of 6. So if I wrote this whole thing out, I would have 5 square roots of 7 plus 1 square root of 6. And I'm choosing to let the 1 be an invisible 1 in the front. These are not like terms, so I can't add them together. That's as far as I can go. Let's check another one really quick. Okay, keeping it pretty simple, pretty similar. I've got 4 square roots of 13 plus 10 square roots of 13. Those are like terms. I'm able to combine those. Minus 6 square roots of 5. That is not a like term, so I cannot combine that together with these first two. So total, I have 14 square roots of 13 minus 6 square roots of 5. Now those two terms, remember a term is separated by addition or subtraction sign. Those two terms are not the same. They're not both square roots of 13 or square roots of 5, so I can't put them together. This would be my final answer here if I was adding or subtracting those radicals. It gets interesting when you think that the radicals are not the same, but sometimes there are some tricks that help force them to be the same. So let's check out an example like that. Let's say we've got the square root of 8 plus 4 square roots of 2. Right off the bat, it looks like they are not like terms. We've got a square root of 8 and a square root of 2. They don't look like they're the same, but the square root of 8 we actually could break down and simplify it. And there might be something funky that happens. If I was to break down the 8, this would be 2 times 4. There's an end. If you've seen my other video, we kind of see how to break down radicals. 4 is really 2 times 2. So now I'm going to rewrite this whole entire problem. I've got the square root of 2 to the 3rd power, because there's 1, 2, 3 of them, plus 4 square roots of 2. Now, what happens with this 2 here? I've got an invisible index of 2, which, if you've seen the other videos, that's the jailer saying, hey, I need 2 tokens to get out of jail. I walk up to the jailer. I've got 3 tokens here. I've got 2 to the 3rd power, which means that I have enough to get out of jail. Unfortunately, I have 1 token left over on the inside, so I'm going to have 1, 2 left inside of this jail or radical sitting right here. So I took 1, 2 out and it cashed in 2 tokens times the square root of, I still have a 2 left on the inside, plus 4 square roots of 2. Now I have like terms, they both have square roots of 2. How many square roots of 2 do I have? I've got 2 of them here, plus 4 of them here. Total would give me 6 square roots of 2. I felt like that was kind of fast. Let's do another one just to make sure we're okay. Feel free to pause the video if you need to. Leave a comment in the comment section down below if you need a little extra help. I can jump on and make another video if we need. Let's go with square root of 80 plus the square root of, okay, let's do the square root of 80 plus the square root of 45. We want to break it down. Right off the bat, it doesn't look like I can combine those together. They look like they're totally different. But if I break them down, maybe I can force them to have the same like terms. So 80 is really 8 times 10, which if I break 8 down, this would be 2 times 4, which is 2 times 2. So I've got 2, 2, 2. And then 10 is 2 times 5. So if I rewrite this, this would be 2 to the 1, 2, 3, 4th power and a 5 on the inside. Let's go ahead and cash in tokens right now. I've got 2 to the 4th power. How many tokens does it take? There's an invisible 2 out here, so the 2 walks up, gives him 2 tokens. He gets out of jail. Then there's another 2 that has 2 tokens left over that gets out. So I'm going to have 2 to the 2nd power on the outside, or 4. So let's just make that a 4. And then on the inside, there's still a 5 stuck in jail. Plus, okay, now let's do this bad boy over here. 45 is 9 times 5, which is 3 times 3. So I circle all my ends. 3 times 3, so I would have radical 3 squared and then a 5. Now, what can get out of the jail here? 3 squared has 2 tokens, so he walks up to the jailer. It's an invisible 2. He's got enough tokens. Sweet. So he can get out of jail. So this would be 3, and then on the inside I would still have a 5. So I've got 4 square roots of 5 plus 3 square roots of 5. Are they like terms? Yes, they both have square roots of 5. So how many square roots of 5 do I have? I've got 4 of them here plus 3 of them here equals, you got it, 7 total. So I have 7 square roots of 5. Notice the symbol in between them would be multiplication. This is 7 times the square root of 5, and I've just simplified it. Hopefully that helps make a little bit of sense. We're simply adding and subtracting radicals. Give this channel a subscribe and a like, and if you have any questions, leave a comment down in the comment section, and I'll be quick to get back to you. Have a great day, and we'll see you soon.